Welcome to the RamTester, a short introduction on how to use it and what features it actually offers. So, operation is very simple. What you need is a USB-C power delivery power supply, or any 5-volt power supply will do. First, you dial in how many pins the RAM has that you want to test. So here I take a 16-pin RAM. Make sure that it is all the way up, the notch is on the top. We just fix it with the lever down. We have 16 pins selected. So we're gonna plug it in. And we can see this one has been tested. It's a 4164 RAM that has been tested. Okay. So let's take another one. We take one RAM that has 18 pins. You can read here 18 pins. So we need to change the dip switches to 18 pins. We just reset. It will automatically detect what type of 18-pin RAM that is. Has been detected as a 4416. You can maybe read it here, 4416. That is completely fine. So let's go on with a 20-pin type. No, actually that's also an 18-pin type. Let us figure out what it is. So that's a 4464. Actually I can't read it because here the markings are really faint. So this one is also working fine. So then finally we go to a 20-pin type. So here I have a zip RAM. So you can see here there is a little triangle on this side which need to go on the left side. So we fit it in here. Triangle is here. So we just reset. And no, we have not completely switched off this one. You can see, check dip switches. If there is something wrong with the dip switches, here we can see on the display. Also the QR code will always bring you to the current documentation that is valid for that version of software you are running. So let's try again. Now we are correctly having a 20-pin type, and you can see it tests. Okay. So this is the basic operation. Now there are two add-on boards that you can use with the RamTester. So first of all, that is this board here, which is the 4116 adapter. What it actually does is it produces two additional voltages, as you can read here, -5 and +12 volt. Each has a little LED. So you can see that the voltages are actually also okay. So you put it in. You can see both LEDs are lit, so this is actually to check that you don't have any short circuits on the power supply or in the RAM, and this RAM is particularly sensitive that both voltages are available, so that's okay. You can see here we have to set it to 20-pin mode. That is already the case, so we just reset, and it's identified as 4116. That's actually the RAM that's inside, and this one is also tested okay. And then one more thing is we can also add this board here. And as you can see, this is a more modern type of packaging for the RAMs. So this is an SOJ type, and it's available for those two RAM types as a 20-pin version. Also here, this one 441000 or 551000, depending on the manufacturing, will fit in here. And you can also test the zip version of this RAM type, which has a different pinout than this socket here. So don't put those RAMs in this socket, that won't work. So this zip socket will do that. Or you can also use the 41256 16-pin socket zip that will fit in here. That's a 20-pin socket, so also of course here the pinout is different. So to show you that this is actually working, 20 pins, we just push reset again. You can see it's identified 514400. So this one is now being checked. It's with a larger chip, and also this one is checked. Okay. So let's head on to some advanced features. First of all, what you can do is the RamTester has a self-test mode. So you switch all dip switches to the off position. We push reset, and then you can see here self-test. And as soon as it starts, it will do some internal tests where you don't have to do anything at all. That's completely automatic. And then for the second test, we test that actually all those connections here are really working. So you need a kind of jumper cable. And then we just pass through all those connections here. So you can see as soon as I touch the connection, the LED will shortly flash. We just go through all of those. And then hopefully everything is okay. And we will get a successful test. So you can see self-test has been okay. And there is another thing also advanced. You can switch all of the dip switches to the on position. This will enter configuration mode. So you can see setup. Now we can configure some behavior of the RamTester. First of all, we have this 32K enable. That is important if you only use like C64 RAMs, the 4164 type, and you never use the Spectrum types like the MSM 3732 or the TMS 4532. It's safe to disable this because it can cause some confusion with the automatic detection. We'll just leave it on for the moment because I will gonna show you some of the 3732s. And so we need to have it on, otherwise those will be detected as defect. Then we have loop mode. Actually, we'll just have one test run. In all tests, everything is run always. So we have like the address line tests, short circuit tests. We have the checkerboard pattern that is being tested. We have retention tests. We have random data tests. And everything is tested twice in different directions. So we also can check for crosstalk, column or row wise, and also the retention is tested to meet at least the specified refresh rates. So that has been, as you can see before, those tests that we have now performed, all the tests are tested. You can't disable or enable anything. Always everything gets tested, so you can't miss a thing. But you can also disable or enable here the loop. So loop will just do continuous testing. So it will continue testing, and you have a counter so you can see how many tests have run. And there is display dimming. If you run in loop mode, maybe it makes sense to enable this feature. And now we will first switch on the loop mode so I can show you different things. And let's have the 32K enabled for the time being. So we exit. So now we have an invalid dip setting, that's okay. Let's go to the 16-pin mode, and I will start with some of those so-called half-good RAMs. Actually, those are like the 4164, but they have identified as defect in the manufacturing process that they were tested, and some defects were noticed. So that depends now in which half of this chip a defect was found. It's either a H or a L type, so in the higher half or the lower half. And this chip has a problem, and that's why it's not a 4164, but a 3732. So it only has half the space that the one we tested before has. It only has 32K instead of 65Ks. So let's see, we have 16 pins, everything should be okay. Let's test this one, and you can see now it could be either of those two. And now this one here really is what it's printed on. It's marked 3732H, and that's exactly what we can read here. And now we have also switched on loop mode, so you can see here the run number, because now it's looping and it's continuously testing until we actually break it. Let's see. So now we have, of course, interrupted it while it was testing, and there was a error was found while testing random data. Let's take another one. Let's see what this one here gives us. That's the same type of the print markings, but here you can see this one would also be possible to use as a Texas instrument, TMS 4532-3 type. That means that this one has less errors than the other one had, so it could serve as either of those two. Let's remove this one as well. Again, we have, of course, an error. And then let's take the last one. So, and then it also happens that sometimes they don't have errors. So probably the manufacturing process had too many good ones, or they had a lack of those types. So this actually could also be 4164 type. So that's important now. What we have seen before, if we switch on and off the 32K, this one would be announced an OK, 4164 type. But the two we tested before, those two here, they would be marked as defect. So if you don't test those, it's really safe to disable this mode. So, and then one particularity with newer ones or RAMs that are a bit newer than ones we just tested before. So that's a 41256 that was used in the early Amigas, for instance. And there is one special thing. If we are running in loop mode, we run additional tests on those. And you can see now this test will coming up. So first, it's all the basic tests that are run, as I mentioned before. It's like address, checkerboard, refresh, and everything at random data. And once this is done, we have this so-called CBR test. And you can see there's a countdown timer. We have a blinking LED every second. So you can see there is actually something going on. It's not defect and it's not frozen or something. We need to wait here. And the problem here is that this CAS-before-RAS, that's what CBR stands for, a refresh test takes a lot of time. We need to be sure that if this counter doesn't work as it's intended to, that we really have information that kind of decays inside the RAM. And at room temperature, it may take quite a lot of time. I have run some tests on those RAMs here. And for instance, this one, the 41256, it could hold its data for up to like 30-40 seconds, while it's specified to only guarantee that for like 4 milliseconds. So you can see there's a big difference. So we really need to wait this 1 minute to be really sure that this counter is working okay and all the cells are refreshed as they should be. Now, as you can see, this takes a lot of time. This test is only run every 10th test, and it's only run in loop mode because this counter is a bit specific. So if you don't really want to test the counter, just to test if the RAM itself, the cells are okay, the addressing is okay, you don't need to run the loop test. So now it's looping again until it would reach loop number 10, and then again it would run a CBR test. But let's skip that now. And we have one more special RAM that we can test. That's an SRAM. And for this, we choose 18 pins because this is an 18-pin RAM. And this one, you need to put it in 180 degrees rotated because it has the VCC and ground pins swapped compared to the dynamic RAMs. So you can see the notch now needs to be down here. We dial in 18 pins. Let's see if this one works. And you can see it has been identified as the static RAM 2114. And because it's only a 1K times 4, it's tested with the March C standard algorithm, and you can see it's tested relatively fast because this is not really big. So it will just loop almost to infinity until we decide to stop the test or remove the RAM, and then of course we get instantly an error. So this is an introduction on how to use the tester. I hope this was informative for you. If you have any questions, just get in touch on the webpage ramtester.ch or on the GitHub repository that is noticed here.